Hello everybody, this is paper 1 from May 2023. This is time zone 2. Alright, five more question. In a game, balls are thrown to hit a target. The random variable x is the number of times the target is hit in 5 attempts. The probability distribution for x is shown in the following table. Find the value of k. So part A asking us to find the value of k. So probability distribution, what does that mean? We're throwing a ball at a target. X is the number of times the target is hit in 5 attempts. So X is number of times the target is hit. So what are we saying? There is a 15% chance that the target is hit 0 times, 20% chance that the target is hit 1 time, k% chance that it's hit 2 times, 0.16 or 16%, 2k that it's hit 4, and then a 25% chance that we hit 5 targets on 5 attempts. So hit the target 5 times on 5 attempts. So find the value of k. So what do we know? We know that the total sum of all probabilities has to equal 1. That is to say, one of these things has to happen. We're going to hit 0 target, 1 target, 2, 3, 4, or 5 targets. These are the only things that can happen, and if we were to sum up all the possible things that can happen, knowing that one of these things has to happen, it would equal 1.00, or essentially 100%. Probability of all of these discrete events, knowing that one of these things has to happen, if we sum it together, it should equal 100%. So, or just the value of 1. So let's go ahead and write that out. So we have 0.15 plus 0.2 plus k plus 0.16 plus 2k plus 0.25. We know that this should all equal 1. So after we have some equation, let's go ahead and solve. And you actually don't need to write and solve on your paper, just the equation is fine. I do it just to kind of show what we're doing here. Okay, so let's go into the calculator and write this out. Menu, algebra, numerical solve. 0.15 plus 0.2 plus k plus 0.16 plus 2k plus 0.25 equals 1. Remember last time it didn't really accept that too well, so I'm going to write 2 times k and then telling the calculator what to solve for. Okay, k is equal to 0.08. Okay, going back to the document here. K is equal to 0.08. The player has a chance to win money based on how many times they hit the target. The gain for the player in dollars is shown in the following table, where a negative gain means that the player loses money. Okay. Here's our table. Determine whether this game is fair. Justify your answer. Okay. So we hit 0 targets, we lose $4. 1 target, we lose 3. 2, we lose $1. 3, it's a tie. We don't win or lose money. We hit 4 targets, we win 1. And we hit 5 targets, we actually get $4. We can't just simply add these up because there's actually a greater probability of some of these things happening compared to others. So in this case, there's a 25% chance that we actually hit all 5 targets. So being able to win $4 in this instance, where we have what is overall a pretty likely event, is something that's quite positive in terms of us winning money. And in this case, although we lose $4 in this instance, this only happens 15% of the time, so it might not be, let's say, as significant. So probability does matter. The probability or likelihood of each of these events will matter. So we have our formula for expected outcomes as just the earnings of -4 times the probability of occurrence. So expected winnings should equal expected losses, and in that sense, a fair game has an overall expected return equal to 0. That is to say, you don't win and you don't lose. In this case, the expected return is equal to 0. So let's write this out. For part B, we have a 15% chance of losing $4 and a 20% chance of losing $3. And K we found out was 0.08, so we have an 8% chance, or 0.08 chance of losing $1. 16% chance of coming out even, I guess. Let's rearrange this. 0.08 times 2 would be 0.16% chance of, in this case, gaining $1. And lastly, 25% chance of winning 4 points. And if we sum all of this up, this would be our expected return, our expected winnings or losses. And if this equals 0, then the game is fair. So let's add this up on the calculator. So 0.15 times -4 plus 0.2 times -3 plus 0.08 times -1 plus 0.16 times 0, I guess that one wasn't so necessary. 0.16 times 1, and then lastly 0.25 times 4. So I'm actually just going to make sure that all of this is incorrectly rather. Good. Alright, and the value is actually equal to -0.12. So on average, it looks like we would expect to lose 12 cents for every game. So determine whether this game is fair. So back at our document here, we see that the expected return is equal to -0.12. So the game is not fair. There's not an equal chance of winning and losing. Fair game, we would expect to have an expected return of 0. Okay, that's it.